Hello viewers, just before the teardown I would like to explain a little bit how the LIDAR actually works. So as you probably know, you can use ultrasound to measure the distance. You transmit some ultrasonic burst and you measure the time until the receiver receives back this sound. You are probably aware of radar, which uses radio waves, and again it measures time between transmitting and receiving. And it's basically same with the LIDAR, where you send a laser impulse and then you're measuring the time until you receive the pulse back. There's one feature that fascinates me and I would like to share it with you. If you are scanning the Earth with a satellite from the orbit, there's one more feature which you can use with LIDAR measurement, and this feature is used, for example, for measuring the height of the trees. So you send your pulse from the satellite down to the Earth and you are measuring the time to receive this signal. But you can do one more thing, which is measure multiple reflections. So if you send one signal down to the Earth, then you get one reflection from the branches of the tree, and then a little bit later you get also reflection back from the ground. That way you can measure the height of the tree and the distance to the ground. I just found this fascinating, so I wanted to share this with you. And now let's move to the actual teardown. Okay, let's revise what I will do with this LIDAR right now. So it's perfectly working, but I have no access for configuration because there is a password to change the settings. The current settings has this rectangle, this is the warning zone, and also I can read the distance in different angles. The thing is that it's really slowly, it's actually updating like once every 2 seconds, which is really slow. To make this more faster, I can change the baud rate, or I can change the sensitivity, and I can also make this measuring angle smaller, like 100 degrees. And to do that I need that password. The factory password SIG underscore PLS, I think, doesn't work. There's a small picture on the internet which says how to find password in this running application, but I had no luck of finding some text strings at these addresses. So I have to find out how to reset this device in a different way. The idea is that SIG for sure has some application which can reset the password, or the password which is stored internally can be changed by some reset. I don't know if there is a flash or some battery backed up memory. So I will open this case and look for some jumper or some reset button, I don't know. And when I will be able to reset the password, then I can change the warning zone, and this device will be more useful than it is right now. So let's move to another step. So it seems that I can get into this LIDAR by unscrewing these 4 screws, in-bus screws. Then I need to unscrew these 4 screws, I think, and the top cover should go up. hope I didn't broke anything. Okay, so it seems everything is holding on this back piece. And that's an excellent design. Look at this. So now you can see the motor. It's probably some three-phase type. Okay, so here are the infrared transmitters. 1, 2, 3, 4, 5, 6 of them. And on the top are receivers. Not sure why there are 2 of them. Here and here. There and there is just a single one. And somewhere in the middle of these PCBs is the laser transmitter and receiver. Here are the 3 color LEDs. It's nice and clever design. Here you can see some heatsink. I don't know if it's for some motor driver. I take a look at that later. It's adjustable. It's a good thing. And here's some high frequency stuff. I found one coax connector right inside here, and I'm not sure where it goes right now. And there's another one which is going also from laser or detector, I guess, and it's going to this electronic board across here somewhere, and then I think the signal goes by this connector is somehow digitalized to this control board with a processor or memory, I don't know. What's interesting, it's this jumper which can be set in one of 2 positions. So I will definitely investigate what is this doing. I haven't found the battery yet, so not sure. Maybe it's reset, so I have to figure out. And this encoder looks really awesome. The purpose of the encoder is to control the speed of the rotating mirror, and the electronics will know the position of the mirror based on these marks. So here is few slits missing, and it's actually few more patterns here, and yeah, it's custom logo in here, and this is the first one again. And here's the stuff that attracts the moisture and keeps it in this bag. So maybe it has similar purpose like this ring, I don't know, this circle, what it's doing. There are no wires connected to it, so I have no idea right now. So I will start with this front PCB first, and then I will take a look closer inside how to continue. It seems like that this PCB has to come off first, then this 1 second. So I will start with this. Okay, here are some spacers, so that will be pretty hard to put them back later. Oh no, that's clever. So when I don't fully unscrew these screws, the spacer will be held by this screw. So, okay, lesson learned. Wow, that looks awesome. Some ceramic hybrid module. So I'm not entirely sure what this is doing. Some RF thing, of course. Here's some amplifier. I'm not an expert in RF voodoo magic. Alright, so I think that this could be a receiver side of the LIDAR. Here comes the signal in, and then it goes to another side where the hybrid module is located, and then the signal goes over these carbon resistors to the op-amp and inside this case, which unfortunately I cannot look in, but I would like to, but I need this device to work actually, so no destruction teardown this time. I looked on the internet. This is some operation amplifier. There are another op-amps, and this chip is 18-bit DAC, so maybe it's setting some offset or gain, I don't know. Yeah, RF magic. So the heatsink has to go away. Wow, and it's well designed. So now I'm a little bit smarter. This chip MAX 507 is 12-bit DAC. Then it's somehow connected to this chip, which is programmable peripheral chip for some interconnection with processor. And this chip actually is the processor. It was made by Intel, and it's a 16-bit MCS96 family chip. I never heard of this chip, but it's a really simple microcontroller, you can see. And here's the programmable peripheral. So I'm getting a little bit scared because there's a lot of boards that I can get out, but hold the thumbs, and I hope I will be able to put it back together and make it work again. I hope that I don't misalign anything. Okay, so I don't have the right tool because I have this ball on the end, and apparently these screws are very shallow. Okay, maybe it's time for some improvement. And it's loose. Thank you, Mr. Hammer. Oh my god, so many cables. So there's a separate board behind this. Okay, so that's the wrong order. I have to start with this board. I just don't want to ruin the mirror in here. And it's loose. Perfect work. Then this should pop out. Okay, one connector left. That one. Okay, it's the same 4-pin 4-pin connector, but it's rotated, so I hope I won't screw that. And it's out. Okay, so somewhere will be laser and somewhere will be receiver. My first guess is that this one is laser and this is the receiver, and it kind of makes sense because this coaxial connector went to this receiver board, if I'm not mistaken. So yeah, this could be receiver and this could be laser. Also, there's some metal mass, so I guess it was for cooling. Not sure why there has to be this big mirror. So now I'm pushing on that DB9 connector and these PCBs are moving. So this is just some interface, and I see optocouplers down there. I will take a look at this board, then this board, and after all, here's the last board which is inside. This is the power and RS-232/422 interface, and this board there's nothing active, or there's nothing much interesting here, just a lot of protection you can see here. And I also like this replaceable fuse. This is nice. And it's a it's a sandwich of two boards. Here are some optocouplers and these interestingly mounted resistors or some diodes. Yeah, these ones. They are standing and soldered on the top. I have no idea why it's made like that. Okay, so far I didn't damage this mirror or encoder, so now it's time to take this PCB out. That could be easily be done by these two screws, I hope. Wow, another connector. Okay. Now I'm thinking why I would need to take this away, because the motor is screwed to this casting and I need to take away the mirror with encoder. So okay, so here the screws are hidden here behind the encoder, so I have to be really careful. Not sure how I reach that one. It seems like there's some Loctite, so I tried that screw. Okay, this one goes more easily, and it is out. Transmitter, receiver, and some op amp, of course, or stabilizer. Okay, what's out? I just don't know. This is a delicate operation because I don't want to bend the encoder. And the motor is free. So now I take away this piece of plastic and I can take a look what's behind this metal. Nothing from the back, just some white plastic. Oh, maybe it's for calibration because it's a really shiny white surface. So when the laser is rotating, maybe it's calibrating its power or reflectivity. Yeah, that should work. You never know how hard it is to disassemble something in the front of a big camera. It's really a bad reach here. So what's the magic behind this metal? So the answer is simple. It's a power supply. I don't think there's much on the backside. So it's maybe like there is coming the 24 volts in, and here are the power supplies for different boards. These 4 pins are cut. Maybe there's some option for another module or a board. Okay, I was expecting some more electronics, but it's a power supply. Also, look at this casting. It's a one piece only. Unbelievable. Not sure what the material is, but some alloy with aluminum. Now let's take a look at the last PCB in the device. These 2 PCBs act as protection because you can get some dirt on the front cover, and these transmitters and receivers can sense whether is there some dirt over here. As you can see, most probably this one is the transmitter with I'm not sure why they use different infrared LED here, because they have small LEDs and this one is a big one. And most probably this is some oscillator which is modulating these LEDs. And on the receiver PCBs there are, no, I'm not entirely sure, but these should be phototransistors. Also it's interesting that they use 2 phototransistors here and here instead of 1, which is everywhere else. So this board should be transmitter because the chip in the middle is multivibrator. And the receiver, I'm not sure, I cannot find what that 8-pin package chip in the middle is for. And this plastic is also well engineered. If you take a look, there are 4 very well polished surfaces, and they match exactly with these LEDs. My guess with these 2 phototransistors here is that because there is a smaller LED, then they use 2 phototransistors, and because here's the bigger one LED, then there is just 1. Also notice that there are 4 surfaces for 4 LEDs, but we have 6 of them in here. And if you take a closer look, you will see that the 2 small LEDs on the edges are not obstructed by this plastic, but it's shining directly to the receiver because there is direct line of sight. So my guess is that these 2 are just for some reference values, and they are comparing the amount of transmitted or received light between these and these transmitters. Well, this is pretty much everything what was inside. One of the reasons I took it apart was because I wanted to reset the maintenance password, and the only suspicious thing is this kind of weird switch. So I'll try to change its position when it's turned on or before the booting process. I've also took a look on these chips. This one is 8K static RAM, and this one is 8K EEPROM. It's pretty nice that they put everything in 8K ROM. Okay, everything is put back together, and now will it work? It works. Red, green, red, green. Okay, now I try to change position of this switch, and I hope that it will reset password or do something similar. I hope it doesn't blow up. Turn on. Wow. Okay, the orange LED is blinking. So something different is happening there. So I've put that jumper back to the original position, and now moment of truth. So it doesn't help. So I stop this video right here, and if you have any information or ideas how to overwrite or change or reset this password, I would be very happy to hear it from you. And thanks for watching. You can thumb up this video, and subscribing always helps. Thank you for watching once again, and bye. See you later.